Here we go, looking at some graphs of some exponential functions. You probably remember something about the exponential function from Algebra 2. Exponential functions look like this. Some constant, a, is raised to the x power. The variable is in the exponent. Our a is assumed to be always positive and not equal to 1, because if a is 1, we have the very trivial 1 to the x power, which has a value of 1 no matter what x is. So what does the graph of this thing look like? Well, you might remember this from Algebra 2, but we're going to take this opportunity to look at our graphing calculator and see how we can get some information from that. So when you first fire up this thing, you may see this screen, and if you do, you want to create a new document. Documents are the preferred method for working with these. We're going to add a graphs page to this document. So that's item number 2. And you can see that we're with F1 equals. You have a total of 99 functions you could simultaneously graph. Although I've never heard of anyone having the need to graph that many. So let's graph 2 raised to the power of x. And I'm just going to press enter. And there it is. And you recognize it. It has a horizontal asymptote, but it's different from the rational functions we've been studying. The horizontal asymptote is only on the left side. And we know it's a horizontal asymptote because there's no way that 2 to any power will ever equal 0. And once you get over on the right-hand side of the graph, as you plug in x's that are bigger and bigger, the y's get bigger and bigger. And so this is what your teacher last year probably told you was exponential growth. I want to graph another function alongside this one so I can compare them. And so to do that, I need to bring back that little graphing window that's up there. So on your calculator, you press Control G, G for graph, and now I'm ready for F2. And this time, let's go with 3 to the x so we can compare them. The calculator is going to make it very easy to compare them, as you'll see, because it graphs each new function in a different color. If you ever need to deselect something, that's always the escape key. The escape key provides you with escape. Now compare the graphs of 2 to the x and 3 to the x. Notice that they both pass through this point right here, the point 0, 1. And that makes sense because when you raise 2 to the 0 power or 3 to the 0 power, you're going to get 1. So the y-intercept of a plain vanilla exponential function is going to be the point 0, 1. Just for grins, I'm going to do Control G and throw another one in there. When I graphed F3, it came out black. And that's kind of boring, and also it clashes with the axes, so you can change the colors of your graphs. If you hover over the graph like this, and then press Control and Menu, you're going to get this menu that pops up, and you go down here to Color, and then select Line Color. And so I'll make it green. There we go. And it changed the label too. So that was kind of cool. So to recap, the graph of an exponential function meeting these conditions has a horizontal asymptote, passes through the point 0, 1, and then rises exponentially very quickly. Now let's compare that graph to this graph. What would the graph of y equals a to the negative x look like? Well, if you think about that for a moment, you realize that that's equivalent to 1 over a to the x, because a negative exponent is just a fraction. This moves to the denominator. And I could rewrite that like this. And so if I go back to my graph now, and if I compare the pink graph to the red graph, which was 3 to the x power, you can see what's happened. The graph of 3 to the x has been flipped over the y-axis. And that makes sense in terms of transformations, because if you remember how the graph of f of negative x was related to the graph of f of x, this graph f of negative x was f of x flipped over the x-axis. So here's 2 to the negative x, and you see how this green graph is the graph of 2 to the x flipped over the y-axis. Okay, now let's talk about how you clear off some graphs here. Control G. I go up. I don't want F5 anymore. I go up. I don't want F4 anymore. I go up. I don't want this one anymore. I go up. I don't want this one anymore. I'm back to just my old friend, 2 to the x. And there's my F1 of x. So they're all gone now. Or are they? Well, there's F2. It's still there, but I've just turned it off. There, I can turn it back on. And I can turn that one back on. And then if I want to hide this thing, remember the escape key is kind of like your universal escape from keystrokes that you don't want. One last thing I want to talk about in this video is transformations. What if I had the exponential function y equals negative 4 to the x minus 2 power plus 1? There's a bunch of transformations going on here, but what was the parent function? Well, the parent function was 4 to the x. Now, what's the x minus 2? What's the minus 2 going to do? Well, that's right. It's going to shift it 2 to the right. That's a horizontal shift. And what's the negative in front of the exponential function going to do? Do you remember? That's going to flip it over the x-axis, reflect it over the x-axis. And then finally, what's this plus 1 going to do? Well, that's going to move everything up 1. So we're going to start with this parent graph. I'm going to do this by hand, then we'll look at how the calculator does it. So first, the parent function. Well, I'm going to just kind of gently sketch it. And there it's going to pass through that point 0, 1. Now you have to apply the order of the transformations pretty carefully. If you don't apply them in the order that they would be done, you won't have the correct effect on the parent graph. So I have to look at this and think, what transformation would be happening first? Well, you work from the inside out. The first thing we're going to do is subtract 2 from the x. That's going to move everything 2 to the right. So this point 0, 1 is now going to be over here at 2, 1. And it doesn't affect the horizontal asymptote at all, and it would just affect the shape of the graph. So the shape of the graph is going to be something like that. Then what would I do next? Well, I wouldn't add 1 next. I'm not done manipulating the parent over here. I would reflect it over the x-axis. So the point 2, 1 is going to become the point 2, negative 1. My asymptote is still the x-axis. Finally, I got to shift everything up 1. And now I'm going to be ready to actually graph it. I'm going to be ignoring all these other phantom graphs here that were just my thinking process. And again, I'm going to base it on what happened to this original point. This point gets moved up 1. Everything gets moved up 1. So the point 2, negative 1 is now the point 2, 0. And the asymptote, instead of being the x-axis, is going to be the line y equals 1. That's mine. And then I can either go back and erase all those other ones, which is what I would do if I were doing this problem as a homework problem or a test problem, or I can just kind of ignore them and just know that this graph is the red graph. Now, one of the things you're going to really like about this calculator, I hope, is that you can use it to check virtually every problem you ever do, except, of course, on a test where it's a no calculator problem. But if you're just doing a problem for classwork, let's say we wanted to verify that using our graphing utility. Well, so here I've captured the screen from my CAS And if we compare that to the red graph on the previous page, it looks like I got it right. The intercept is 2, 0, and it does appear that the horizontal asymptote is y equals 1. Okay.